So locally it's being recorded, and it's being recorded on big blue button too. So we had no questions, so let's start. All right, and so we talked about operators, and we said we have binary operators. Binary operators return values, and they are represented as member variables with where the left operand is actually the owner of the operator, and the right operand is the argument that is being passed to the operator. What the operator returns is what the uh, operator is going to return. And the ones that do not have side effect, they must be constant. So in this case, either a constant passing argument by value, or they need to be constant passing the argument as constant. These are the ones that do not change the uh, do not have side effect on the operands. An example from the standard operators that we have in C, plus is one of those that it doesn't change B, it doesn't change C, and it returns a value. The ones that have side effect, they either receive, so if they have right side effect, which doesn't exist in standard library, I cannot give you an example, is the one that changes the right one. If for to implement that one, you pass the right one by reference, which means you have access to it. You can actually change it, and you make the operator constant, which means the owner, that is the left operand, is not changeable. These type of yeah, and it returns an A type based on whatever it's supposed to do. Either A type or A type reference, we don't know. It depends on what we want to design. The one that have left side effect, they're they the operator should be able to change the owner, that is the left operand, therefore they are not constant, and the right one is should either be passed by value or a constant reference, preferably. Okay, so that's that one, and let me just do something over here. All right, now, yeah, because passing by value is expensive. If it's just a primitive value, I understand. But if you're passing an employee or a big thing towards, it's always better to pass a constant value. Oh, did we give any examples on those? These are, so binary operator review. That's the binary operator review that we had from last time. We reviewed it, so we don't need to do it again. Binary operator with side effect. We had right and left side effect in this case. So we have the insertion operator changing the container that we have at right, and also change the current container. And we said that we want to simulate pouring. So we pour from one container to another. So we move values from A to B. This binary operator changes both sides. That was the explanation for that one. And left side effect is plus equal or minus equal. You already have it from the last time. Uh, then we went to, let me go to the operators again. Then we talked about unary operators. We said unary operators are they don't have any argument because they are the member of the variable, and because the standard unary operators comes at before the operand, they are all, the one that is usual and doesn't accept any argument is prefix, which essentially whatever operator you create, if you don't pass anything over here, it means this is a unary operator. Now, uh, people are asking, can I make plus equal a unary operator? The answer is no. Remember, what we are doing is, so this is wrong. You cannot have A type, B type, operator plus equal. You can't do this because plus equal by nature is a unary operator. It's not a is not a it's not a, is a binary operator, not a unary operator. Because it's a binary operator, and what we are doing is essentially overloading, that you should never forget that you are overloading currently existing operators, which means you're going to change their meaning. It means you cannot create a new one. This is wrong. You can't do that. You can't make a binary operator unary if by nature it doesn't exist as unary. Do we understand this? And if you reply no, please activate your microphone and talk right away. And Manny and Fadi are not replying to the poll. All right. Next one. So that's unary operator. And we said the postfix unary operators are kind of unique. There are only two of them. So it's not unique, just two of them. So you have a plus plus and a minus minus. These are prefix operators that like the other ones. But if you actually make it postfix, then you have to have a plus plus and minus minus and put an int there. An int over there doesn't mean anything. It just means that this one is a postfix implementation. And as I mentioned, the postfix action that you have inside, um, as with the regular plus plus, where actually it happens after the fact, doesn't apply over here. If that's the case, you have to implement it yourself, and we'll explain how later. Then we talked about index operator, and we said index operator is a binary operator. The left, the what it stands before the index. So what is being indexed is uh, the left operand. So essentially, I could say what is being indexed is the left operand, and therefore the owner of the operation method. Okay, which means in here B is being indexed and C is the index. The index itself is the right hand operator. Right hand, the right operand, and therefore the argument of the operation method. So when I say A is equal B index C, what happens is that B will be the owner of the operator overload, and whatever we are passing from right side will be the index that is being passed. The one that has side effect is not constant. The one that is without side effect is constant. Okay, and usually either returns by value, or if it's returning something by reference, it must be const. Okay, so for with side effect, these two are perfectly okay. Without side effect, it should return a constant too. So it is constant and returns a constant if you are returning a reference. Are we okay with this? Okay. All right, next. So, and the example for it was, so we don't need side effect over here, index overload is this one. So in our integer array, what we have done, we said we're going to remove the element method and replace it with the operator, index operator. And we're going to pass an integer as an index. And this is what we are going, we're going to return a reference that's going to be essentially the reference of the element. And the modifier version of it is not constant and returns a reference. And the query version of it is constant, which means it doesn't change the operator and returns a constant reference of what we have. And because of that fact, we can actually now use either the operator itself, which is silly to do. Let me see. I have 2C of these. This is not the one. Yeah, so I don't know why it's all out of sequence. So yeah, as I was saying, this operator over here, operator, I am calling the method itself, not using the index. It is exactly the same thing as using the index. So the two over here side by side shows how I am. It has one extra line. Yeah, so this one shows how I am using the method name to call the index operator. Here is the operator call itself. So B5 is 500, or operator index 5 is 100. 5 is the index that is passed. That is the right one, and this is the same. And we can do the exact same thing for the other ones. And the one that is being called as a constant reference automatically will be the constant implementation. So the constant implementation will be called when the object is constant, therefore, and the one that is actually being overwriting the elements, that's going to be this one. Are we okay with the index operator overload? All right. Okay. So that's the index operator overload. And then we talked about typecast conversion. For typecast conversion, let me take the array off, and we're going to use that later on for something else. All right. For typecast, for type conversion, we said that, where is the type conversion? For type conversion, yeah. So type conversion essentially means casting. This is the C style. But in C++, casting is essentially B-type AI. Okay? C++ style. Now, this is accomplished in two different ways. Either you overload the typecast, which essentially you are saying if a B-type as A1, if an A1, let me see, I'm casting A1 to B-type. So I wrote this wrong. People. This is A-type, B-type const. Because I'm casting this to B-type. So that was wrong, and I have to fix it. So let me go open up the other one from the last session. So if you use that was wrong, it has to get fixed. So B is equal to B-type A1. Essentially, you're going to have A operator type. So you are casting A to a B-type. This is the right one. Okay, and for this one, I have to do a commit. So we know that it's actually changed in Git. Where is it? This is 345. We need 244 notes. And I'll get here and I'll commit this one. Commit. Corrected the typecast overload template. Okay, so that's that one. Just be aware of it. Let me remove it. Yeah. So so essentially what we are saying over here is that whatever you are casting the object to, this object should have a typecast conversion operator to be able to be casted to the type. So whatever type it's being casted to, operator type is what is going to be used. Now in our type conversion, we use the container. So we essentially said, if I want to convert the container to whatever thing that I have over here, so I want to convert that one to an integer, I need to create an operator int typecast to convert the container to an integer. So the operator int is a cast to an integer. Okay, now please remember that operator overloads do not have return type. Uh, Typecast overloads do not have return type because they are the cast. They are because they are indicating the return type in the cast operation. So this type, let me just put it beforehand. And remember, we don't have a return type because it is already saying what is supposed to get returned. So you don't want to double it. And that creates the typecast operator. Are we okay with the typecast operator? All right, at the end, when we were at the end of the class, we explained how we can have a binary operator. I explained that like when I have a binary operator like this, it's a plus between a B and a 3. As I have over here, I can overload it. And in my overload, where is the container? So I actually did the put the container in a separate thing so it becomes tidier. So what I have to create is something like this, which essentially tells uh, this is the container that I'm gonna get, and I'm gonna add it to another. Oh, sorry, it was a plus and an integer. Oh, there we go. Here it is. Sorry, this is the one. This is the one. So it says add an integer to me, to the container, and return a new container out of it. So what happens is that in that binary operator overload, binary operator overload, it says give me an integer. I'm going to add that integer to the value of the container, and together I'm going to create a temporary container created to return it out. So this temporary container over here is a container that is built with the value that is coming in, that value that it has, and it's returned. Therefore, it is not going to change the current one. And this was creating a binary operator with no side effect, which left side is an object and right side is a primitive value. So in this case, left side, left operand. Let me put it in here. Where is it? Left operand is a composite type. Right operand is a primitive type. When I say composite type, what do I mean? What is the meaning of composite type? Please answer.
Pass.
Okay, next one. Alexander, what is a composite type? Anybody wants to answer? What is that, Alexander? Why people are not ready
Ah,
to answer? Oh,
sorry, pass.
pass. Okay, so somebody, any volunteer to tell me what is a composite type? Raise
Uh,
your hand. Oh, okay, good. Levu, go ahead.
I guess like a type which has multiple types in it.
Yeah, exactly. A type that is built up of other types. As easy as that, people. Any class, any structure is a composite type. An array is a composite type. A type that is built up of other types. Now, other types could be composite or non-composite. It doesn't matter. But any type that can be broken down into other types, that's a composite type. A primitive type cannot be broken down into smaller pieces. So an int value over here, that cannot be turned out into smaller pieces. Int is an int. It's an entity that cannot be broken down. But a container can be broken down into an integer and if it has something else. Anyways, it's built up of other things. Now, do we understand this? All right. Okay. Thank you. All right. So now that we understand this, let's create another scenario. Now, I want everybody's attention. Do I have everybody's attention? I'm going to ask a question right after this. You better be all ears. Okay? Paul, Manny, Grace, Fadi, Christian. Okay. I'm not seeing that you guys reply. So, anyways. So let's start. Now, this is all good and dandy. Now, what happens if I have something like this? I want to say A is set to 3 plus B. If I want to write something like this, then what happens? If I want to write something like this, then the left side is not a composite type anymore. In here, the left side is a composite type. Because of that fact, I could make the operation that I want to design a member of a container because the left side was a composite type. If I say A is equal to 3 plus B, now 3 cannot have methods. It's a primitive type. And because of this fact, I cannot use a member operator overload. One more time. The case that we are having problem with is that when at left side of an operator you have a primitive type, because of that fact you cannot overload the operator as a member operator since the left side cannot have a method. Do we understand this? That brings us to helper functions. We can, so when, this is when we need helper functions. Now, what does a helper function do? A helper function over here is a function that is standalone function. It doesn't have any, it doesn't belong to anyone. Now, in this case, because it's going to be tightly in work with the container that I have over here, I'm going to put it under the container class, but it could be anywhere. Okay, so if I have something like this, this is where we create a helper operator overload. Helper operators are not a member, and this is how they work. So I'm going to come over here and I'm going to create a new session saying non-member binary operator overloads. So if I have A is set to B plus C, if I have this scenario and I want to create an operator overload that is not a member, this is the template for it. It returns an A type. The name is operator plus, sorry, at sign, it means any binary. Okay, and then at left side it receives a B type, and at B type, and at right side it receives a C type. Now obviously this method, this function that I created cannot change B type and C type because they are not, they are passed by value. So in here I'm going to say no side effect. Or if I want to be efficient in my coding, if I want to be efficient in my coding, I should pass a constant B-type reference and a constant C-type reference. So that would be the signature for it. Now, in our case over here, at left side, I have an integer. So I know it is going to return a container, so I'm going to call it a container. So that's the signature for it. Operator plus is what I want to create. At left side, it receives what? At left side, it receives what? Muhammad, where are you? Oh, your microphone is not working. Okay, next, another person. Please test the microphone before coming in. Please test the microphone before coming in. Select again. Yunji.
Constant integer reference.
Fantastic. So it was a beautiful response. Constant integer reference. But think about it. Integer is a primitive value. It's not a big thing. I don't need to pass a constant integer reference. In this case, it's better to use the pass by value thing. So I don't have to worry about anything. In here, I'm just going to say integer left operand. Do we understand Yunji? Am I pronouncing probably Yunji? Is that correct?
Yes.
Okay,
Yeah,
fantastic.
yeah.
Do you understand why I didn't? Your response was perfect. But what I'm saying is that when what we are passing is not a ginormous thing, just pass by value. You don't need to pass by reference. Is that clear?
Yep.
Okay, fantastic. Now, the next person is going to tell me what is the right side, right hand operator, right hand one over here.
Uh, I have to pass.
No, you don't have to. Just
Okay.
just tell me exactly what Yuan G said, but instead of int, put a container.
Instead of input, just the container then.
No,
Container reference.
constant container reference. Right
Ah,
operand.
okay.
All right. See? It was easy. All right. So take a look at it. At left side, I have an integer. At left side, I have an integer. At right side, I have a container. It's ginormous. It's a big thing. That's why I'm passing a constant container reference right operand. Okay. And then I have to, oopsie daisy. And then I have to, because it's returning a container, I cannot return a reference first because it's a function. Any container I create over here will die after the scope is over. So I have to return something by value. Therefore, I need to create a container. Now, in here, I'm going to say container. So this container temp that I'm creating needs the left operand being added to the m value of the container of right hand operator. Now, who can tell me what should I add this thing, put this thing over here to extract the m value of container? There's going to be a percentage for the midterm.
Do you need a getter function? Getter method?
Don't I have a getter method already?
Yeah, use the getter method.
Which one is it?
Uh,
Smart guy. You have to mention which one.
Right
Which one
operand.
extracts the value of the container?
As a hello, professor.
Yeah, go
It's
ahead.
right operand
Alexander,
dot m value.
pardon me?
Right operand dot m value.
Okay. Right operand dot m
But
value.
we're
M
outside
value.
the
But
container.
wait a minute. That's private. I can't do that. So what do I put over here to extract this?
Operator arrow key or
Nope.
something.
That's it. This this arrow thingy inserts one to another. You can say put B into A. It has nothing to do with, it returns an integer, but it has nothing to do with extracting the integer out. I'm gonna wait here for 3 years. That was the last thing we talked about before, actually before.
Is it this pointer?
No,
Oh, the
this,
cast.
first of all, you said this. That's a major sin that you said that, because this is not a member variable. So this doesn't have a meaning in here. This doesn't have a meaning. This only has a meaning inside a member operator. Okay? So what do I call?
Uh, can we just use the right operand because we have the operate casting function is public.
Ah, who said that?
I said it. I'm Anderson.
Anderson, you just got 2% for your midterm. Okay?
Thank you
We
so much.
just created a cast that casted a container into an integer, and what it returned was the value of the container. Therefore, it's done. Now I'll go over here, return temp, and now the operation is actually implement. The operator is actually, uh, let me just put over here 30, is actually implemented. So a.display. If you listen carefully in class, people, you can all get these 2%. And by the way, Anderson, so unless another person receives a 2% for anything, okay, or 1% for anything, you cannot answer. Remember that. Okay, so we have to give chance to others. All right, so now if I run the program over here, we will see that, oh, we have errors. Let me see what is there. Container operator plus yada yada is already defined in object. Operator
I
plus.
think we need to put the code in the CPP file instead of the
Oh, I didn't
.html.
put it. Oh, yo. No, no, yeah, but you're right. I forgot. Sorry about that. Let's copy. I made a mistake. Thank you. There we go. Okay, so now when we actually run, as you see, this calls the operator, which is a member, and right side is the m value is 0 and the right side is 3. Therefore, m value is 0. Didn't we make? Oh, we moved b to a. Okay, let me do it again because I saw that there's nothing in there. Let's do it again. Let's run it again. No. What's going on? Stop. Let's run it again. Okay, so now we go inside, and as, why is it? Am I changing? What's going on here? I think this This is not the PRG I'm changing, people. Copy. Give me a second. Why is it thinking so hard? Something's fishy, people. Give me a second. Don't save. Okay. Remove, add existing item. This looks good to me. And let me make sure that other ones are correct too. I'm going to remove my container array. I'm just afraid that I added something from the other directory by mistake, so I just remove them, and I'm going to add them one more time. Add existing item. Add existing item. This is today's lecture, and we have 2, 3, 4. Add. Okay, let's recompile. And let me see if I change the other PRG by mistake. No. Let me see. Something's happening with my Visual Studio, people. Just opening a file is taking half. Oh, it crashed. Okay, I knew something was wrong. Recover selected files, please. Okay, I'm gonna stop this anyway. Stop. Okay, and run again. Restart. Something was wrong with my Visual Studio. It crashed. It needs an update, but I don't think it was that important. Let me try one more time. Okay, so let's try. I'm gonna make this one 40, and I'm gonna start F10, and let's see what happens. I think this one is better. Okay, so it comes, oopsie daisy, stop, one more time. Okay, so it comes over here, it goes to the plus operator. The right side is 3, as you see. Oh, the value of the left-hand operator is 30, which is B, and right side is 3, so it essentially becomes 33 and returns it and goes back to A display, and when it displays, you're going to see 33 is printed, which is A. Now it comes in here, left side is integer, right side is a container, therefore it goes to the helper operator, and now we know that the left-hand operator is 40 and the right-hand operator is 30. Therefore, it creates a temporary container by calling the int cast, returning the value out, going into the container, building a new container with value 70. So therefore, temp will have 70 in it, and it returns that one out to A, and A will be overwritten by that, and when it displays, it's going to show 70. Are we okay with this? So this was the case. This was the case in which we had at left side. So when do we write helper operators? Non-member binary operator overloads. We write these in 2 cases only. One, when left operand is a primitive type and cannot have a method. Therefore, helper function is needed. Therefore, helper function is needed. And you see, I'm calling it helper function. I'm not calling it helper member operator overload. We all know member operator overload are just functions. Like it's just a function that happens to be an overloaded function. So there's no big deal with that. Are we okay with what I just wrote over there? So the second circumstance in which we actually create a helper function is when left operand is operand is a composite type, but the source code is not editable. Or does not belong to you to modify. So you borrow a class from me that does something for you, and you want that class to sit at left side of an operator as a left operand. But because this class is written by me and is being used in 5 different places in a company, you cannot change its source code. Therefore, you are not allowed to add a method to it. Or the object you are using is a system object. Is an object that exists in C++. You're not supposed to go change the compiler. In that case, again, you create a helper operator overload. Do we understand the second one? I'm going to give you a very easy example for it in 3 seconds. Okay? So take a look at this. Take a look at this. Down to this point, I keep saying display, display, display. I don't want to do that anymore. What I want to do is this. Take a look. I want to say cout the value of A is, and I want to put over here A and L. Value of A after A is equal to B plus 3 is, I want to do this. I want to write this expression. So if I do something like this, now A in here does not have any case in which, like cout doesn't know what is A. A is a container. And I'm going to actually bring this one over here too. Now, funny thing is that if I run this, you'll see that magically it's going to work. But it says, you see that it says 33, it says 70, but it doesn't say CNT70. CNT70 is the one that I want to get printed, not 70. So when I run this, and it says it's 33, it's 70, who knows why it is working? Because A doesn't have anything to do with cout. Cout has no idea what a container is. How come it is printing its value? Can anybody tell me for percentage and midterm? We explained it last time in class.
Because it has a private integer attribute. Remember?
Because inside it has an integer attribute. Is that what you
Yes,
said?
the end value. Yes.
Okay, you just violated C++'s encapsulation. The whole idea of encapsulation is that M value is a private thing. How does cout know what is inside the container? It has no idea.
It has a type hash, the operator int.
Yes, thank you. So you got the 2% for the midterm. Yes, because C language always tries to cast this to work with cout, it checks all the types that cout can support. One of the things is an integer. Cout can print an integer. Now it checks, can I convert a container to an integer? Yes, I can. Therefore, it's going to print it. It's not good because I want CNT dash to get printed. I want the container to be printed like this. But because the compiler knows how to convert it, it just runs it. We don't like it, but it runs somewhat. Do we understand this? All right, now let's fix it. Let's fix it to actually get printed properly the way we want. Now, can anybody tell me what type of object is at left side of A when A is actually in this statement? What do we have at left side of A? Let me do it this way. Please answer me. What is the type of the object that is at left side of A? What is the type of the object that is at left side of A? Keep going, keep going. I want everybody to print, to write, and then after you write, it's going to be anonymous. You're not going to see who's doing what, who said what. Is it? I hope so. Keep going. Tichia, Muhammad, Siongak, Athurat, Arawit, Mani. Okay, so let me just publish this thing. So take a look at the thing over there. 1% says O stream. That was me. Okay, output stream, a reference to O stream, and the rest is wrong. So those three first ones are correct. Now let's analyze one by one why number 4 is wrong. Why we don't have O stream in here. Why we don't have string in here. Although at left side of A is that one, but how compiler compiles the thing, it starts from here. First, it runs this one. So cout and this together will print the value, and it will be replaced by cout after it's printed. Then after it prints it, I have cout and A, and hopefully if we design this properly, this should return another cout, and that should print end L, and the whole line is printed. Do we understand this? Okay, so what we... Anderson, you said no.
Sorry, I just want to listen to you explain one more time. I think it's okay.
Sure. We know that in C language, by default, statements are analyzed from left to right. So the very first thing that compiler sees is cout, insertion operator, and a string. So the very first thing that it analyzes is this statement. Cout, and the result of that is the string being printed into cout, and as a result of that printout, that operator returns a cout. So the very first thing that happens, one, this gets printed, this gets analyzed. So one, this is analyzed. And as a result, this is printed and returns this that is cout. Okay? So this is the first thing, which means this is analyzed or executed. This is printed, and operator return this, that is C out, because it was a member of this. Number 2, and so therefore the statement is changed to, therefore the statement is changed to C out, A, and L. Now that it's done, compiler wants to execute this. So what does it have? C out at left, A at right. This is what we need to overload to make this work. And it has to exactly work like the first step. If we accomplish that, then A will be printable by C out. Do we understand this?
Yeah, I got it. Thank you.
Perfect. Now I want everybody to get it. All right, so let's do that. Now that we know C out is of type O stream, we know that what we want to design, again, we're going to come over here. We're going to do that. So the operator we are overloading, operator, is this one. At left side, it receives an O stream. But O stream is C out. C out is printing on a string, so it needs to change this console. Therefore, we cannot make it a constant. It has to be modified, and the modification is the printout. So I have to say std o stream left, or reference left operand. Now at right operand, what do I have? At right operand, I have an A. Because I have an A, it's going to be a container. So definitely it's a container. But what type of container? Does it need to be a reference? Keep going. I want everybody to answer. Does the container need to be a reference? Keep going, keep going. Again, I'm not going to say who said who, so don't be embarrassed. Answer, and then you can analyze yourself by the answer you gave me. Okay, Grace and Christian are not participating. Please participate in these things. Good for your health. Anyways, so take a look at the outcome. 67% said yes, and 33% said no. And the answer is yes. When you print something, nothing changes. Remember the display? We made it a const, which means, oh, no, sorry, not that one. A container is a composite type. It's a big type. Because it's a big type, sorry about that one, I gave you the answer for the next one. It's because it's a big type, you never pass it by value. We learned that from IPC 144 when we passed everything by pointers. So it has to be a reference because it's a big thing. You don't want a copy of a big thing to be passed. Now my second question that I answered is, does it need to be constant? Does this need to be constant? Please answer. Does this need to be constant? Leo. %71 said yes and 29% said no again. Of course it has to be constant. Remember our display was constant? When we are printing something, logic dictates you are not changing it. You are just printing it. If you make a copy of a book, the book doesn't change. It remains the same thing that it was before. So we have to make it constant. Logic dictates it. C++ doesn't. You can pass it by reference without a constant. It will work, but it's wrong. Do we understand this? All right. Now, next. So far, so good. Now, what does need the operator to return? The operator, for it to work, it needs to. So in here, the the uh, the what did I write over there? Oh, so I'm gonna say now I'm gonna say 3 will be executed cout a operator cout will be called. Because cout doesn't have it, we had to create a helper, right? Will be called. And let me implement it. I know that this is, I'm not writing the thing, so I'm going to implement it over here like the other one, then I'm going to move it outside. So let's put it over here. So the operator is called, and so this one's going to be write operand. And now that I have the write operand in here, I can simply say write. I don't know why I don't put the T over here for some reason. Write operand dot, it has a display, right? So I'm going to call the display. And because it's constant, it will work perfectly. So will be called the A is displayed, the A object is displayed, printed, or whatever. Okay, etc, whatever. Operator, oh, the operator will return to continue the cascade effect. Now my question is that what do I fill those 4 question marks with over there? What should the operator return? Keep going. I want everybody to answer. Think and answer. And look at option 1. What option 1 is doing, this has to do the exact same thing. But the exact same thing is the exact same value. Okay? The operator returns Five people are not answering. Okay, I'm gonna publish the poll and we're gonna take a look at it. Look at the poll over there. Okay, number 1, O stream, wrong. It doesn't return O stream because O stream is not an object. It cannot be passed by value. O stream cannot be instantiated. O stream has only one instance that you can use, and that's cout. So O stream is not that. You're right that you say O stream is supposed to be returned, but it's not. O stream by itself cannot be. It has to be a reference of O stream. So very close, but not right. This is absolutely wrong because we are saying operator over here returns this. It doesn't mean that this has to return this too. The operator over here is not a member operator. This doesn't have any meaning. When I say it returns this, I meant cout because cout was the owner. So essentially, cout dot operator yada 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 returns this. Therefore, this in here is cout. Those who said cout are wrong again. It's cout reference, not cout. Okay? Containers wrong. 33, I have no idea what does that mean. CNT 70, I have no idea what does that mean. O stream reference is perfect. That's good. The CNT, no idea. Reference of left operand is perfectly good. It makes sense. O stream reference is perfectly good. O stream by itself, I know you meant O stream, and so on and so forth. This, that is cout. Okay, so so cout was correct, but not this. So the explanation that you gave, it shows that you know cout is supposed to be returned, but you have problem with this. So I'm replying to everybody's thought on this so we know exactly what's going on. So in here, first of all, what is being returned is O stream reference. This is absolutely correct. What the statement which I have to make is this reference. This reference is a new name for cout. So that is what is going to get returned. Therefore, in here, I have to say return left operand. And now my operator is written. I don't know why it's giving me an error. Cannot overload functions by return type alone. No idea what it says. Anyway, so I'm going to copy this. Oh, and this is std. And I'm going to copy this and make it like this and go to the container.cpp and add it down here. Okay, so that's the function that is written. So returns reference of cout to continue the cascade, which means therefore the statement is changed to cout and L, which prints a new line, which goes to new line. Prints a new line, goes to new line. Do we understand this? And this, ladies and gentlemen, this, what you see, is a universal way. Now I'm going to fix all the good things that you have, and I want your attention over here. Okay? A universal way, or the standard way of creating a display function where it's supposed to print something on cout. This is how it's done, and I want you to listen to me carefully. I am correcting it right now. So for the container, anything, anytime that you have a display function or print function or view function or anything that it's supposed to display a composite type on OStream, the standard way that programmers do is like this. We write over here display and we receive an std OStream reference over here. And I'm going to call it OSTR. And by default, you set it to cout, which means if they don't mention where they want to print, because OStream can represent many things you're going to see later on. But if they don't mention where, it's going to print on cout. Now, in here, I'm going to have the same thing, which is OStream reference OSTR, and in here, instead of cout, you will write OSTR because that's the new name for cout. And in your overload, what you do in here, you pass the left operand to display, Actually, let me do something in here. Control Z. You know what I'm gonna do? Uh, let me Control Z everything first. Go back to what it was. I'm gonna bring back to what it was before. Don't worry about it. And I'm gonna go to container and remove this one for now too. Okay, save everything. What I'm gonna do is in here, I'm gonna go in here and I'm gonna commit this so you can see what the difference was. So let's commit all, and I'm gonna say, yes, in here I'm gonna say overloading helper overload for printing on cout. Actually, let me commit only these, the container.h and prg.cpp. Where is it? prg.cpp, prg.cpp, prg. There you go. So I'm gonna commit these, commit and push once. Okay. Now I'm going to, yes. Now I'm going to come over here and go back to what it was before. So that's cout. Then I'll come over here and I'm gonna go there. You go. Save. Commit. Helper. Commit and push. So as you see, I am putting different points of return so you can see the diff and see how it got fixed. Now, what I'm going to do in here is this. So please pay attention now. Please pay attention. So as you see, I'm saying the O stream will receive OSDR and print cout. And then in container over here, I'm going to do the same thing. I'm going to say over here, the display will receive O stream reference OSDR. And instead of cout, I'm going to use the OSDR to print it. So whatever O stream they send me, it's going to use that one to display, not only cout. Therefore, in here, when I'm printing, I am passing the left operand to display. So whatever is in the line of cout, if it's cout A, cout will be left operand. If it's something else, I'll show you in 2 seconds, that's going to be the one. That's going to be passed to the display. And because your display is already returning that value out, what you can do, you can simply say return it. So this way that you see that I have done this is the standard way to overload a class to print on cout. You should be able to do this with your eyes closed. Okay? Again, you create a display that receives an O stream, defaults it to cout, and returns an O stream. Any workshop we give you that has a display, even if the signature is not like this, write it this way because this is the correct one. Then you overload it like this to be able to make the object to pass through the display of your class and then go back and go through. It's like you're making a passage to go through everything and pass the printing object to print everything all the way through guts of your class, and then it's passed by to continue whatever that is going to be the reference over there. So now when I run this program, you will see that it goes like this. And when it just comes over here, adds that. As soon as it comes over here, it comes to your class. So now left operand over here will be cout, and it's passed to display, so it comes to display. So OSTR is cout, and it will print the value out. As you see, it prints this instead of just the value, which is CNT33. Then it comes back out, returns the cout back in here, and that brings it to new line. This is another one more time. First, this is called, it goes to the operator, left operator over here. Left operand is cout. Cout is passed through the display. Therefore, O stream is cout, prints everything with cout, comes out and prints it and goes out. Okay, so this is the standard way. Are we okay with this? Now, you only know about cout. There are actually two more objects that you can use to print stuff out. We have what we call clog and cerr. These are all OStream objects, but written in three different ways, so you can actually use one for your log, one for your error. So if your cout fails and doesn't work, later on you'll find out how, but cout might fail, then you can actually log it with another one. Now if I run this program, you will see that this is printed. And when it comes to log, now it goes to A. Now your left operand is clog, not cout. Goes to left operand, and now a log is getting printed over here and comes out. And now an error is being printed. So it works with all different objects of type OStream. Do we understand this? Now, again, I want your attention over here, which is going to bring something easy and breezy over here in 2 seconds. What if I want to say something like this? Now, first, let me just push this first, because this is important. So this one, and this one, I'm going to say commit, and I'm going to say correct way of member display methods and insertion operator overload for OStream. Okay, commit and push. So now you know. So you can actually look at the diff, and when you look at the diff inside the on the webs, what happened? Something is wrong with my computer, people. I think soon I'm gonna be in trouble. Close all windows. Can you hear me? Somebody talk if you can hear me. Can you hear me? 1, 2, 3. People at home, can you hear me? One. One. Hello everyone, I'm back. Sorry, my Chrome crashed and closed everything. Can you hear me, everyone?
Yes.
All right,
Yes.
Yes.
fantastic.
Yes.
Okay, so
Yeah.
I'm gonna put this thing at left side. I just wanted to demonstrate something and then it all crashed on me. So after the class is over, I'm gonna restart my computer, but let's finish this first. So you can see the page right now. I moved to Edge for now until I'm done and fixed. So what I was saying is that when you are going, if you when you go to class study, no, not class study notes, when you go to where is that? In class notes, you see it says correct way of member yada yada yada. You click on that and then go over here split. When you go on split, you can see exactly what it was and what did I change it to. You see that? So it shows you the change, every change that I made, that it's a correct one. This the last left one is a crappy one, the right one is the correct one. As you see, all the changes are over there, so you can actually see how it's done. Are we okay with this? Let me start a poll. Start a poll. Start a poll.
Trey, could you show again how you go to the split view?
Oh, there's, you see this?
Yeah.
Click on that, it goes to split. This is unified. This is split.
Oh, okay.
Okay.
Thank you.
Okay. So, and in here, I'm gonna go. So everybody's okay with this? All right. We lost some people, I think. Some people actually left as soon as he's gone. Yay, he's gone. Let's quit that thing. Anyways, so let's finish this thing. So this is the way it's done, and I'm just gonna show you. Now I'm gonna show you this. Take a look. Let's say I'm gonna save this as over here. I'm gonna call it a dot dash c out operator insertion operator main.cpp. Okay. Now I'm gonna go into this one and I'm gonna create I'm gonna come over here, remove all these things. Just imagine that I'm gonna do this. I'm gonna write over here see out I'm gonna have A and B over here. What is the value of a container? And I'm gonna go like that, and then I want to be able to say or of the container, and in here I'm going to say C in A. Okay, so or what are the value of the containers? Okay, I'll do it like this. Okay, containers like that. Okay, and I'm going to write over here B. So I want to be able to receive from C in and put it in A. So what do I need to do? First, I need to have a read. Your read should be exactly like this. Take a look. I'm just going to copy that. Instead of O stream, it's I stream. Instead of read display, it's read. Instead of O stream is I stream. So I'm going to call it I stream. And instead of stand C out, it's C in. Okay? And obviously it's not constant because I'm reading it. Okay, so that's going to be the prototype for my read. Are we okay with that? Sorry, one more time. Are we okay with that? Fantastic. Then the next thing I want to do over here is what? Implement it. So I'm going to go over here and I'm going to say, okay, iStream is my CN. So in here, I'm going to say cout. First, I'm going to prompt something if I want to. Cout, enter container value. Or let's not do that because that's hidden logic. I don't like it. It should be only cout. So I'm going to say over here, I don't have a util, so I'm going to just go istr into m value, and that's an integer I'm receiving, right? And after I do that, I'm going to say istr dot ignore 1,000 characters and backslash n to make sure that I don't have any garbage afterwards. So I'll do it like that. And I'm going to say return ISTR. So I'm receiving one integer, putting it in a container, and clean it up afterwards. So that's my ISTR. Now I want this thing to work everywhere. So what I'm going to do, I'm going to go to my container exactly like this one. I'm going to copy. This is iStream. This is extraction operator. iStream left operand. Obviously not constant because I want to change it, and that's my operator. I write the code for it. What do? I'm going to say return right operand dot read left operand. Exactly like that one. So this is the good way of writing it, but just to see how it works, I'm going to come over here and do this. I'm going to write it in a bad way with hidden logic that I told you. We are not supposed to do this. I'm just going to do it so some action is happening over here. So I'm going to say over here, cout value, and I'm going to do like that. So you see something is happening in there. Because I'm cascading it, I want to cascade information to be seen. I'm going to say cout, you entered A and B. Okay, now when I run this program, first I'm going to run it. So as it runs, the overload will be called, and it says, something is about to. Okay, one more time. When I write, there you go. What is the value? Didn't I go to new line? What is the value of the containers? And I'm going to go to new line and L, run it. This is the first value, so I'll put over here 30. Right value, I put over here 40, and you hit enter, CNT 30 and 40. So as you see, when it runs, it actually goes like this. It's exactly like cout, no difference. So it comes over here. The first one is getting executed, which is cin into A, left side cin, right side A. The extraction operator overload will be called. It passes left operand, which is, what did I do in here? How did it print? Right up. No, that's right. It passes left operand, that is cin, into the read of right operand. Therefore, right operand's read will receive cin. It goes right up here. So ISTR is cin. It prints a value. Now it waits for the user to enter the value. User enters 30, hits enter, and value is put over there. And because it's ended with enter, that enter is removed. We have a clean keyboard, returns the value, comes out, goes out up over here. Now it returns cout, IStream, sorry, and IStream is cin. Therefore, this will be replaced with cin, and cascade will call the second one, and therefore the second one is called, which is 40, and it goes back over here, and then after that, life is beautiful, and everything runs perfectly. Okay, do we understand this? Fantastic. And that's essentially helper operator overloads. And I have 3 minutes to tell you something in here. Actually, you know what? I'm not going to tell you that. I'm just going to leave it as is. Okay? I'm just going to mention one thing for you, and then I want somebody to remind me next time to, let me see, how much time do we have? We have to, oh, we have 7 minutes. Oh, we have 7 minutes. Never mind. I'll explain. Okay, so you will see in books, workshops, questions, you will see things like this happening. Take a look at this. Remember this operator overload that we have done. Oh no, not this one. Which one was it? This one. Operator plus that we have done over here for write operand in container. When I was actually doing the write operand, somebody told me instead of doing this write operand dot mValue, and we said this is private. Do you remember this? Okay. Some books say this is okay if you write it like this. Because this is a helper operator, you can give the helper operator access to your class by making it a friend. So essentially you copy the prototype of the function, and then you bring the function in here, and then you write friend, and now it has access to your class. So this becomes a friend of your class, and therefore the program runs. Okay? So, and I'll save this one, and I'm going to go over here and in the OOP244 part, and in here I'm going to say commit using a friend instead of a query. Okay? So essentially what I'm saying is that in here I'm using the display. I told you this is the standard way. I could just make this a friend and not even call the display. Go to the guts of write operand and print it. Its mValue anywhere I want it. Now I have a question, and I want everybody to think about it. We have 5 minutes. Be quick about these answering. I think you can answer this very nicely. Okay? So now please answer. What are friends good for in life? And I want you to answer it to me right now. Very quick. Keep going, keep going. Hurry up. Quick, 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 quick. Keep going. Xiangjun, Paul, Manny, Yen, Gustavo, Grace, Christian. Keep going. I see funny stuff over here. All right. And I'm going to publish. So you'll see the answers over here when I publish it. And I'm going to stop sharing the screen for a second and kind of attract your attention. So helping each other, help and support, companionship. What else? Share secret, friendship, help us but still be individual, helper, help each other, access classes, private data, support us. And somebody says, I don't know. Helping each other, no idea, to help us. Okay, now, you know what friends are good for in object orientation? And this is something I always mention in class. Let me just see if I can clear this. Or I can go to the next page. So friends are good for this in object orientation, people. Knife in the back. Friends are just to betray you in object orientation. You will never, ever, you are never, ever, allowed to use a friend for your methods. Using a friend for a method, it means lack of object-oriented design. It means you were lazy to create a query. And because of that, you gave the key of your house to your friend to come home, instead of watering the plants, steal your wife's gold necklace. And that's what friends are good for in object orientation. And I want you to really, really pay attention to what I'm saying. And this is extremely important. Extremely, extremely important. Friends in object orientation are the worst thing you can do, and you should never use it. You never ever give access to your class to a non-member function. Ever. The only time friendship is allowed is for ownership. You have a pet, you have a dog, you love your dog. You say, my dog is I am my dog's friend. You are a friend of your dog. You're not. You can take your dog to the vet and you can put it down. That's not friendship. You own that dog. Remember that. Never use friendship for your methods. Only friendship is allowed for ownership, which will come later. Do we understand this, hopefully? And this is my last question. Do we understand this? Thank you. All right. That's the session for today. I'm going to change that code back out of friendship and put it back to the normal one. And hopefully we know what's going on. Never, ever use friendship for your methods. Remember that. Have yourself a beautiful, beautiful day. I will post I will push everything right now into the repository. Go through the operator overload and all the good stuff. Let me know if there is anything missing the next time you're coming in. Any questions before we go? Any questions? All right. Thank you very much, people. Have yourself a wonderful day, and I will see you soon. Bye, everyone.